For example number 3, we're going to get even more complicated, and that's okay. We have tangent of theta times cosecant of theta divided by let me read that again. Tangent of theta times cosine of theta divided by cosecant of theta times cotangent of theta. So now I have 4 trig functions, and they're all inside of a fraction. What do we do? Well, don't panic. Just follow the steps I've taught you in the previous examples. For the first step, you're going to turn everything into sine and cosine. Again, we do that because once everything's in terms of sine and cosine, it's much simpler to simplify. So this tangent of theta is going to quickly convert. Let's use a different color here. Let's use, we'll use green. Tangent of theta is going to convert to sine of theta over cosine of theta. Okay? Now the cosine of theta is going to remain the same. However, on the bottom we can convert those. Cosecant of theta, as we've proven before, is equal to 1 over sine. And cotangent of theta is equal to cosine over sine. So now we've taken all of this and we've converted everything that wasn't sine or cosine into that. So now we have this big mess, but that's okay. This is nothing more than a complex fraction, which you learned to simplify in my Algebra 2 class. If you have any questions about simplifying complex fractions, you can ask me, or you can go back and watch those examples. So now we have sine over cosine times cosine, all divided by 1 over sine times cosine over sine. The next step is to simplify that. The first thing I want you to realize is in the top of the fraction, you can cross the cosine up here with the cosine down there. If you don't see that, you can see that that's just cosine over 1, and now you can see that they cross cancel. On the bottom, there's not much you can do for canceling, so we're just going to leave it like that for right now. But what will happen is the top will now just become sine because it's sine over 1. Now I'm just going to combine the bottom since nothing canceled, so 1 times cosine is cosine up here. On the bottom, I'm just going to write sine times sine. Now you might think, well, why don't I just write sine squared? Don't square anything until you've simplified everything down into not a fraction anymore, okay? Or at least remove the complex fraction first so that you just get a simple fraction like that, and then go from there. And you're going to see why we do that. So how do you get from that step to that step? Well, again, you're just basically you're keeping the top, so you're keeping the sine of theta. You're changing this to division. You're changing the division to multiplication, and you're flipping the bottom. Keep, change, flip. So it becomes sine of theta times sine theta over cosine. So we basically have 3 sines of theta on the top here and 1 cosine on the bottom. You might be tempted to say, oh, well, that's just sine cubed over cosine. No, we don't want to do that because you can actually see that sine over cosine is equal to tangent, right? So once you get to this point, if you can simplify 2 trig functions into 1, you want to do that. Your final answer should not be a fraction. It should just be an expression, right? And you'll see why that is in a minute. So the next step, as I said, sine over cosine is equal to tangent. And I've even circled that here. So that's just going to convert to tangent. Then what I'm going to do is move the other sign out front. So now we have sine times sine, which equals sine squared. And that's we're going to drop the tangent down, and that's going to be it. Sine squared times tangent of theta. So we've basically taken this fraction right here, we've eliminated it and converted it into one single expression that's not a fraction. The final answer is sine squared over tangent of theta. Now, I do want to explain that you could have just taken the last sign and divided by the cosine instead of the middle one. For some reason I just did that. However, you can take the last one and divide and get tangent. You'll get the same answer. But I do want to talk about why you don't want to write sine cubed over cosine of theta. Can you see that sine cubed over cosine of theta is not as simple as our final answer? That's what we want to do. We want to write as simple as possible. And again, one single line is simpler than a fraction. So whenever you're simplifying, make sure you convert anything that is a ratio back into a trig function so that you don't end up with a fraction as an answer. That's it for this example. If you have any other questions about it, let me know.